A changing climate may not necessarily lead to more floods and droughts, according to Swedish researchers who have reconstructed weather patterns over the past 1,200 years. Scientists used data collected from tree rings, marine sediments, ice cores and mineral deposits to examine the interaction between water and climate in the Northern Hemisphere over the centuries. Using this to create a spatial reconstruction of hydroclimate variability, they found no evidence to support simulations that showed wet regions getting wetter and dry regions drier during the 20th century. Dr. Fredrik Schapentierl-Ljungqvist, a medieval historian and paleoclimatologist at Stockholm University, explains the climate reconstruction showed a prominent seesaw pattern of alternating moisture regimes has been consistent over the past 12 centuries. Climate anomalies such as medieval megadroughts in the western U.S., and monsoon failures in East Asia during the 15th to 19th centuries, have occurred in this period and are larger than anything recorded with modern instruments. This strongly suggests that the instrumental period is too short to capture the full range of natural hydroclimate variability, he writes in the journal Nature. Comparing the proxy data with climate models, Dr. Ljungqvist reports there is large-scale agreement from the 10th to the 18th centuries, but this breaks down in the 19th and 20th centuries. He said there are several possible explanations why models may not accurately simulate hydroclimate variability. The proxy evidence does not support the tendency in simulations for wet regions to become wetter and dry regions drier in a warmer climate, Dr. Ljungqvist explained. This is in contrast to many existing climate models, which generally show an intensification of the hydrological cycle and more extreme wet and dry spells during the 20th century. There is an absence of evidence that the weather patterns predicted for higher temperatures have actually taken place. This suggests that either the warming in the 20th century was not strong enough for the pattern to emerge, or that the triggers for the mechanisms responsible should be revised. Ljungqvist concludes that his approach of gathering multi-proxy evidence, accompanied by a millennium-long perspective, is crucial to be able to accurately evaluate hydroclimate simulations. The findings from the new study don't disprove that the Earth's climate is changing or that certain regions are experiencing more extreme localized climates, desertification or localized flooding, but they do question some of the modeling and simulations which have been used to link climate and the water cycle.